This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better. Hello, I'm David Carston. Professor Kingsley Dixon, a distinguished researcher and academic, stands as a pioneering force in ecological restoration and mining environmental science. Well, look, I think we need some context about you, Kingsley, and where you've come from. I mean, you hold a professorship at Curtin University now, but your story started quite a while ago now, and it's been a storied and an altogether exquisite career in botany. And to become an expert in biodiversity, you're a doyen of Western Australian botany. But every story has a start. Where did your love of plants begin?
I guess I was born with a natural inkling. Then that was cultivated by parents who were avid gardeners, never formally trained. They never finished high school. And then a grandmother who was an absolute 5-star vegetable grower, camellia grower, and had ponds. And that's where I got my great love of building fish ponds and stuff. But I guess where I got into the nitty-gritty was native plants and Western Australian plants when I was young were not accessible. There were a couple of little books. They all had complicated names. And then there was just some pictorial books. And we used to go on little family picnics to the hills, often into gravel pits because they were always the ones with the best wildflowers. And things like blue leschenoltia and the red and green kangaroo paws just looked like the most special plants. But I couldn't say the Latin names. My parents couldn't say them. But then Nana Sue Harper came into my life.
Now, who is Nana Sue Harper?
So Nana and Sue Harper were two women who established one of Western Australia's first native plant nurseries, 1959, about 1960. Extraordinary women devoted to native flora. As a kid just in primary school, I walked through their front entrance because I begged my father to drop me off one day. He left me there for the whole day. I had my lunch. He went back to work.
It was a different time, Kingsley, wasn't it? When you could drop your kid off somewhere.
It was a safe time. And I just knocked on the door and the relationship started. And they were the ones that just demystified for me the Latin names.
So were they university educated and then applied that to it?
They both did nursing degrees. They both were heavily involved in World War II. They lost their fiancés there, and then devoted their subsequent lives to both native plants and Aboriginal child health care. So that's where I also got really involved with understanding the plight of First Nations, particularly First Nations children, which stays with me today.
Well, that understanding of connection to country and to the flora of Western Australia is something that you have obviously been familiar with for most of your life. And has that coloured your direction of research and what you've favoured in terms of what you studied in botany over the years?
That is spot on. For my PhD, I had a wonderful mentor in Professor John Pate, who came to UWA in 1972, and I started my PhD in 1977. And he was one of the world's leading legume physiologists. This is crop legumes. Now, you couldn't get more poles apart than West Australian native plants. And he saw me as his entree into understanding this bewildering diversity, which he couldn't understand. He was a very good Irish botanist. In fact, ran his own gardening show in Northern Ireland for a few years because he was an ace veggie grower. If you couldn't eat it, you didn't grow it. That was his view. And so we got on really well, and I became his eyes and ears into the flora. And
so was it really a two-way kind of exchange of information and knowledge?
It was. His legume physiology was inconsequential, but he came with a wonderful plant physiological, how plants grow and develop, which I greedily saw the values of, munched it all up because I could see we could start telling the stories of how do Western Australian plants survive on the poorest soils in one of the harshest places on Earth and have for 20 to 30 million years. More climate changes than you could imagine. And even today, I look at the forests. Yeah, it looks dry, it looks poorly, but it's saying, I know how to win this battle. And through that mentorship and me trading that sort of insight into the flora, we developed a great research collaboration which went on for many years, and including my time into Kings Park after my PhD. And we subsequently wrote a book from my PhD on plants with underground storage organs, which was the subject of my PhD. Although the amusing story is John Pate said to me when I got my first class honours degree in 1976, he said, "Oh, good, so you've got first class honours, you'll come on to a PhD, I gather." I said, "Oh, I would love to do that." And he said, "Good, what would you like to do?" I said, "My great passion is Western Australian orchids." And there's this uncomfortable silence. I just challenged a legume physiologist with the concept of working on the ecology of orchids. And he quickly looked at me, brush of the hand, and he said, "Orchids are too hard to grow, they're too slow. You can work on plants with underground storage organs," which I accepted heartily because all of our orchids have underground storage organs. So it was a sort of backdoor into my orchid fascination.
Well played by the young Kingsley Dixon, indeed.
Yeah, I got
Well
my
played.
orchids. Yeah.
You got what you wanted in the end. Now, you mentioned Western Australian orchids being very difficult to grow, and at that stage, really quite poorly understood. Did your research sort of extend further into your career? Has that been sort of running in parallel to your professional positions?
Orchids, have been those sort of things where once you get the orchid bug, which I got when I was 8 years old. I remember seeing my first white spider orchid, which, we've got these wonderful things, common orchids, and I just was enamoured. I couldn't believe this thing. Got Rika Erickson's little book, Orchids of the West, and used to read every page and pore over the pages and gradually tick off all of the species. And back in those days, they were clearing all around us. And so I used to go on big rescue digs on weekends.
Right.
My wheelbarrow and trusty spade, little kid, walked off into the bush and would come back with pots. And my parents tolerated my gradually growing collection of bush orchids. From that point all the way through to today, we've retained a strong research interest with the research group. We've got a big collaboration with Royal Botanic Gardens Kew with the orchid specialists there, which is right in midstream, looking at climate change impacts on West Australian orchids. I've had a number of great collaborations and students on pollination, but the really important stuff has been the conservation, where we've worked on some of our rarest orchids to try and rescue them through seed propagation, which is complicated because all of our orchids have a special partner. They don't do it alone. Mm-hmm. They cheat on a fungus. Fortunately, fungi aren't that bright, and the fungi gets tricked into providing nutrients to the orchid, and the orchid in exchange can give it a little bit of its photosynthate, the material that comes through from the sunshine on the green leaves. And all of our orchids all have unique relationships, and often it's species specific. And that's the work that I took into Kings Park, and we developed one of the biggest orchid programs in Australia, which has now grown orchid programs in other botanic gardens, both in Australia and overseas.
Fungus and orchids, it sounds so salacious, but entirely transactional. You mentioned Kings Park, a massive part of your career, but it was a very modest beginning, wasn't it? Talk to us about how that got underway.
So originally I applied for a position at Kings Park just out of my PhD, and the position was for a research assistant to the director. And I thought, a botanic garden job. Oh my God. I didn't get it.
What?
I was deflated. And so I waited another 4 months, and then the director phoned and he said, "We have another position coming up. It's for a display botanist. And I thought, right. So I asked him what's involved, and he said, it's putting up information pamphlets, taking tours, and then if you've got spare time, you can do other things botanical. And I thought, okay, I'll do that. And had great fun. That's where I met lots of people, and I actually learnt guiding and information pamphlet development and a whole lot of stuff. But the great thing was I managed to do that quickly but efficiently, which gave me a little bit of research time. The one thing, though, when I did ask about the research position at the interview, I remember they said, yes, we have a lab. It's got microscopes. Yes, it's very good. But I should have gone and seen it.
What did you find when you opened that door for the first time?
What did I see when I walked down the hill on my first day? A tin shed and a little door, and I opened the door on the tin shed, and there was this musty old laboratory. It had one microscope, which I thought, oh gosh, that's from East Germany, the really cheap versions. They're the real dodgy ones. And it had really been left a little bit abandoned for a number of years. But I thought, it's somewhere to start. It had a little rickety old air conditioner, I remember, was more noisy than anything, and a telephone. So we were very modern. And we began there with some of our early programs in that little building, and then it gradually grew up to what it is today.
And what is it today? And over that time period, with your involvement there at Kings Park, did you study? What sort of research headway did you make?
So the research was never funded at Kings Park. There was no budgets given. There was no central budget. So if you wanted to do research and fund a field trip or go somewhere exciting to get rare and endangered species, you had to drive your own car, pay your own fuel and all the rest, which wasn't a problem. But it was the very early days. In fact, just 2 years, about 1984, after I took the position at Kings Park, that I had a call from a mining company. They were operating in Eneabba on mineral sands. And they said, we understand that you know a bit about native plants. We've got a rare species. We're wondering whether you could work on it for us. I said, yeah, that'd be fine. But Eneabba's a long way, and, could you fund somebody to give me some assistance? So they did. That was our first research funding. And it was all very novel for Kings Park, who'd never got any money. It was all state-funded material, and they all thought this was very amusing. And then suddenly other people started turning up in the lab, which everyone was really quizzical about. Who are these? And
what are they doing?
Yeah, and where are all these white lab coats coming from? But that was really the ignition point on multiple strands. And the first strand was threatened species. Working on that species, I got to understand the plight of West Australian plants for the first time. So that was very early in that starting part of my career. The second part was working with industry to try and come up with effective solutions after they've got their approval. Now, that work continued, expanded and grew into the programs that when I left in 2015, we'd grown it from me and a East German microscope to a really fantastic facility of about 50 research staff and PhDs. We had research outputs of around 40 papers a year coming out, so we're one of the most productive of global botanic gardens. But importantly, we were one of the leaders in innovation in species conservation.
Before we go down that route, because that's a really interesting avenue to explore, did your changing understanding as the head of that research team of Western Australia's threatened species, did that change the overall remit of Kings Park and Botanic Gardens' role?
It was interesting because up until that stage, it was the State Botanic Garden. It was developed as one of the great unenclosed, free entry, 24/7 botanic gardens, but devoted to the indigenous flora of the region. There was only one other place, and that was a little botanic garden in Los Angeles, Rancho Santa Ana. And they were the two gardens with this concept that, we're in a hot spot, we've got these amazing plants, why don't we just have a garden about them instead of bringing all the imported things in and having this sort of hodgepodge Irish stew of plants of the world, which is all very interesting, very much the Kew Garden style, which is, fantastic and amazing garden to go to. And that was a smash hit. But the garden was really a garden for pleasure. It didn't give any messages. And when we started the first of those programs on threatened species, and then I started getting involved with networking through other colleagues at that stage around what we could see was happening in Australia, that is, we were finding more species going from common to rare than was comfortable, that Kings Park then installed its first, it was called the Rare and Endangered Garden. And that was fabulous, had amazing plants put in it, had good visitation. And then ultimately in some of the main displays that they still have today, they still have threatened species sections to highlight to people both the issues of where we've taken our plants, but also potentially just some of the solutions that you can do through solid research.
Well, through that solid research, our collective knowledge, thanks to you and your research team, has expanded greatly. And one of those areas was germination and some of the discoveries you made in that area. Talk us through that, Kingsley. It's absolutely fascinating.
Yeah. Look, I'll let the secret out now. I was never that interested in seeds. Everyone seemed to work on seeds. And I thought, well, I like working on whole plants. So I was very much interested in the whole plant. And then gradually, the whole issue that came from that first threatened species, which is called the hidden beard heath, Leucopogon obtectus, for those inclined in the Latin way. And but there was an intriguing thing. As a kid, there would be a bushfire. We would always go the year after a bushfire, and the bush was amazing. There would be all these plants germinating, and 2 years later there'd be all these flowers and all of this. And we all knew there was this regeneration from bushfire. It is what our plants have got resilience to, and it's something they respond to. And seeds loomed large with our rare species, and then with a whole swag of other research programs that we got on. How do you germinate seeds? So I became the reluctant seed scientist and now love them. And there was this perplexing problem. A third out of our 12,000 species, 4,000 species, we can't germinate on demand. You put a bean seed in your garden or a tomato seed, you water it, what happens? It comes up. Right. They've lost their dormancy. You plant a wheat seed, it's lost its dormancy. Its ancestral wheat has dormancy. That's why we don't grow them with dormancy, because they're easy to grow. But our West Australian plants, with those very long periods of geological stability, have learnt the tricks of the trade. And there are particular reasons that we've now uncovered in their ecological adaptive capacity why they do this. But they'd locked in their secrets that they'll come up after a fire, but you could put bags of seed in. And it was Kings Park who said, kangaroo paws, red and green, the state floral emblem. We put them in, sometimes they come up, sometimes they don't. We just put in lots of them and we get enough up. And I just kept thinking there's got to be something, and they come up like hairs on a cat's back. Even in Kings Park bushland after a fire, that was, you go 2 years after and the red and green kangaroo paws carpet the landscape. And we then got on to, like everybody else, and thought, aha, it'll be the heat from the fire or the ash from the fire. They're the two things that fire makes.
How long
But it didn't make a difference.
How long did you study those two elements?
Heat and ash?
Yeah.
We were on that for probably 5 or 6 years.
Man.
Everybody else was.
Yeah.
And we just thought, well, we think there's a soil aging, or we think there's some other thing. So we're just going backwards and forwards on this until I went to a little seminar at an obscure conference in, of all places, Rio de Janeiro. It was a Botanic Gardens conference.
Sure it was, mate.
Yeah, the caipirinhas were delicious and abundant. But there was this little seminar. There were probably 10 people in the audience, and there was a South African stood up and said, oh, blah, blah, blah. We've been blowing smoke onto one species on a hillside in South Africa, and we got some seeds to germinate.
Hello.
The penny dropped. What was the third thing that comes from a fire that's obvious to us? Smoke. You know, we were lighting little experimental fires, you know, wiping the tears out of our eyes, not realising all the time the stuff in our eyes was the stuff they were after. And the rest, as they say, is down to history. We made the discovery for Australian plants that indeed many of those 1/3, those huge number, that 4,000 species, were in fact responsive to the smoke from the fire. That just exploded onto centre stage in 1995 when we published the paper. It caused great ripples in the Australian research community because overnight all the heat and ash people suddenly were out of a job and out of research grants. So that wasn't intentional. But it transformed the nursery industry. It's interesting. I returned to Nan and Sue, who started me on the journey, and I was sowing seeds in their nursery, and they said we never sow those because they never come up. You know, so
Yeah, why bother?
why bother? And I went back. They'd long since sold the nursery, and I shared with them seedlings that I'd grown with smoke and told them of that story. And in their senior years, that brought enormous joy to them. That I said, you started this, and now it's at this point.
Oh, that would have been so satisfying and gratifying for them.
Yeah.
That they opened their door to you, and many, many years later, this was the payoff. You've become a giant of research into Western Australian flora, and you've come back with such an amazing discovery, in tandem with your entire team, of course. Now, with just on that, with the smoke, you went one step further. You decided to isolate the chemical that caused.
Yes, look, I think
the active chemical.
I think science always progresses when there's a big helping of naivety. That is, I thought this will be simple. We'll find the chemical in smoke. You know, we've got this stuff. We can put it in water, bubble smoke through water, and then we can soak the seeds and up they come. So it's in the water. So that's easy. We'll identify it. And so we started. 11 years later, we were literally down to Lamington drives to try and get, because no one would fund it.
Yeah.
Because after about 3 to 4 years in the pursuit of a discovery like that and not getting hits, your funding dries up. It's a very interesting lesson in how science operates. You know, the high risk stakes, believing that this could be worthwhile and pursuing it. And it was interesting, in that 11-year journey, there were 2 other groups in the world also that we connected with, one in South Africa and one in the Max Planck Institute of Plant Ecology, really high-powered machine with equipment from the stars. And I got on really well with that team, and we didn't share how we were travelling, but we shared frustrations. And they then withdrew. It was an informal race, let's put it that way. They withdrew, and I remember they wrote us a lovely, lovely letter, because they did those in those days, pre-emails, a lovely letter saying, look, it's we're closing this down. They said it's using up enormous amounts of resources. It's not getting us anywhere, but, you know, if we can help you out, we wish you well, and all the rest. And so on we pursued. What we did as typical Australian researchers, we spun it all on their head. What those researchers didn't do was they didn't have a rapid, they had one species they could use to check for the chemical. Mm-hmm. We had a whole lot of them, so we could cross-check with those. The other thing that we did was and it's with the wonderful chemists that we collaborated with at UWA, who are just remarkable people. We took the spectrum of the chemicals, and, you know, my naivety was we didn't realise there was over 4,000 chemicals in the smoke. So within that millisecond of ignition, 4,000 chemicals are produced.
That's phenomenal.
Which one is it? Naturally, everybody else thought it would be one of the big ones. So they were looking at a more quantitative thing. They're looking for the thing that was coming off the most. what we then discovered, we didn't do that. We decided to break the spectrum up along the long axis and just take subsamples and check with our rapid germinating species to say when we get a hit. And the difference in that is the time, but also the chemical turned out to be one of the rarest in smoke, which ecologically didn't make any sense. If you're going to use smoke, why wouldn't you use something that's super common? These are the tricks of nature, and there are a whole lot of reasons for that molecule in the end. So in 2014, we published the paper. The patent was lodged in November 2013 because it was a brand new molecule. It's a tiny little molecule. We celebrated the Noongar culture by calling it carrageenolide, which carrick is Noongar for smoke. Olide refers to the particular chemical structure that it has. And that chemical has gone onwards to be in an entire new group of growth-promoting hormones, new to science, called the charrikins. And every time you look at a tree, charrikins are helping it to get branching patterns. And it's just amazing that a little bit of work in this West Australian bush with smoky hair and eyes led to that whole molecule being discovered. And still today, all these years on, we have active programs, and they're ramping up again, looking at smoke interactions in seed, because we're now on a whole new phase, still working on that same species from Eneabba that we never actually clinched the germination.
So the saga continues.
We're never going to stop until we get the hidden bed heath to germinate.
His persistence, Kingsley, persistence. Now, that period of your career at Kings Park, how long did that go for, and what are some of the other significant, discoveries and initiatives that you were part of?
Yeah, look, the research freedoms, and that's a fundamental ingredient, research freedom, was allowed to blossom. That inquiry would ultimately lead to good outcomes and great science, and there's no greater truism. You can't performance manage high-quality research. It has to come from down in the belly and from the heart and just well up in people and have that freedom. And so Kings Park grew from those days to the large group that it had. I managed to, being in a botanic garden, go to many of the great botanic gardens, developed collaborations with about 11 of them, which was pretty heavy work, maintaining but terrific partnerships. And we were able to bring back breakthrough technologies. So we were the first research group in the world to finally crack cryopreservation, that is the freezing of organised plant tissues in liquid nitrogen. It meant we could take our threatened species that I could see were in big trouble, and we could finally lock them in space and time in perpetuity. That took us almost 5 years to get the first species to work, and then we were gradually working through others. The second side of the research program was developing the threatened species restoration research program. This is growing up species using often quite complex technology, including tissue culture, including fungi, which we did with the orchids, and using those for reintroduction programs. But guess what? We were running out of bush to put them in. Everywhere we went where these were, they were often just a roadside population. There was one species, the Corrigan grevillea, it's a wonderful thing, had gone extinct. Someone knew where the location was. It was one of the few sites where we applied what we call in situ smoke. That is, we took our smoke tents out. They looked like little Telstra tents that they put up over their little holes in the ground.
Yep.
Much to the amusement of rural people, seeing this drum being stoked up and these little tent and these strange botanical people. And when we saw the seedlings erupting from the ground, we realised that we could save it. And the local community then adopted it as their floral emblem. We got the farming community on board, but we had no land left. We could now grow it on demand from seed, but we had no land left. And that's when we developed the third large arm of Kings Park, which is how do you restore bushland? And back to my roots. My beloved Banksia woodland that I was raised in Beachborough is now a threatened ecological community on the Swan Coastal Plain. Who could have imagined that?
Well, certainly not you as a 12-year-old, right?
No, in my short lifetime. But we were able to put together packages where you could understand how bushland should be put back together so you can then put homes for threatened species. But we also discovered just how complicated it is. And just as we're still working on those niggling species, and there's many of them that we cannot germinate, we still can't put my beloved Banksia woodland back together. So it's a bit like Humpty Dumpty. We've got bits and pieces still missing. So that's the journey that we're now full steam ahead. I've taken that Kings Park work and expanded it, and we've now got a major program called the Australian Research Council Centre for Healing Country. It's the Indigenous-led restoration economy. It's giving First Nations a chance to develop a means of returning our bushland, their bushland, the bushland of my childhood, back to good health. And
after we've cleared it, essentially?
That's right, yeah. And we have, in the southwest, we have just 30% left uncleared. In 200 years, we took 20 million years and reduced it to just 30%. It's time to pause, think, and rebuild before it's too late.
Kingsley, that work that you undertook at Kings Park, you've just mentioned that you've adopted that as part of an independent initiative, but you've also taken that into your work here at Curtin as well. Could you tell us a little bit about your work here, both in terms of the restoration side of your expertise, but also the cryogenics as well?
Yeah. So the cryogenics is now more in the physics of cryogenics. Why can't you put every species into cryogenics? We've now redirected our focus because that's staying with the people more specialised in cryobiology. And I look forward to seeing the major breakthroughs there. Back to home turf, the nitty-gritty of how can you grow every species effectively and how can you put back 1 million acres a year. We cleared in the 60s as a kid. There was a catch cry, 1 million acres a year put to the plough. And I thought that was good. It was something called progress. In fact, we had the local Morley Progress Association, whose primary role was to knock over the bush. And I just thought it was all inexhaustible because as a kid, there was just this stuff that went on.
But didn't we all?
Yep.
Right? We all would have thought that.
Well, we think of it, of everything with nature, that nature is inexhaustible and has an extraordinary ability to rebound no matter what. And, today as I was walking here, the Carnaby's arrived, as they do in Curtin campus, which is one of the hotspots. And we're trying to work with Curtin now to donate 100 macadamias so we can get some fast food options for Carnaby's. But looking at those birds here with their bubs reminds me of what we've done. They're now critically endangered, and we're not certain of their trajectory, but we now need to do everything we can, which includes rebuilding bushland, which means in the home garden doing things differently.
Well, let's break it down to brass tacks here. What is your position here, and what is your domain, and tell us a little bit about your student cohort.
So I'm a professor of botany and conservation biology, restoration ecology. That's a bit of a mouthful, so I just say I'm a botanist, and everyone smiles. And we have a significant postgraduate and postdoctoral research team who are working on multiple simultaneous aspects, everything from seed to more effective ways of using seed, native seed, dormancy breaking on demand, building capacity with Indigenous communities. And there's a broad remit. It even includes developing through restoration an Indigenous honey supply chain, using the bushland that we rebuild to develop Indigenous owner-produced honeys from restored, damaged lands. And I'm confident that where we're going is the right way. My anxiety is the clock is ticking. and we don't have a decade anymore. We have 5 years to get the technology toolkit aligned and operational to begin delivering large-scale restoration. We need to be able to put back more than we're putting back as proper bushland if we're going to provide those homes for threatened species, if we're going to give Carnaby's cockatoo new homes amongst the gum trees, which they haven't had for many years.
Well, it seems to me, as you tell us about these various strategies, that you've got a multi-pronged approach. There are different avenues of research taking place that are all part of an integrated, almost, picture to tackle this issue. But where you have provided the expertise and your researchers have provided expertise and solutions, the other half of, or the other side of the coin is policy at a government level and industry engagement. Now tell us about both of those. Are you making headway?
I sit on a number of boards, advise on a number of committees to government, and industry are listening. The technical know-how that we need to address the problems is falling short in terms of an alignment with policy that enables industry to make a more, and any developer, Main Roads Department, rail authorities, for them to make an informed, evidence-based decision that what they're about to do is going to be an irreplaceable loss of nature. It's not nature positive, it will be nature negative. And that's where the policy, I believe, is still lagging and it needs to be brought into a more contemporary lens. It's interesting that we now live with a population that when I was a kid, the bulk of Western Australians were connected to the land and the bush. Now 9 out of 10 Western Australians have never been in a piece of bush because they're urbanites. So we're disconnected from the reality of what's happened on those landscapes and the urgent need for change, and in wanting and demanding that the policies of government provide for future generations something that I had. I have a colleague, and she spoke very eloquently last September in Darwin at a big international meeting that I was convening. And she said, we have to think 7 generations ahead.
Why 7?
Because we're only 5 generations from the Industrial Revolution that has given us the problems of the planet. So we're by 7 generations since the Industrial Revolution, most of it will be gone. So what we do is now plan, what will the country look like in 7 generations? And I think with the present rate of loss, it's not looking like a place that's going to be good for our plants and our animals, and certainly a place that won't be the wildflower state by a long shot. So it's about aligning policy with where we've come from and the reality that we can't patch this easily. It's going to be a very complicated pathway, and each year that we're delayed is a year of greater net loss.
Well, Kingsley, at this juncture in your career, it's looking increasingly like your time is spent less in the lab and less in the classroom and more about, lobbying for change. And that seems to be a large part of who you are and what your role is now.
Well, I'd like to call it informing people and policymakers of the reality of what we're now facing and the duty we have to those 7 generations in the future. And there is a great duty that we hand something over where they can enjoy the extraordinary things that I have and present-day West Australians all enjoy in our wonderful natural environments.
Kingsley, always a pleasure to chat. Thank you very much for your time today. Really appreciate this.
Thank you very much, David.
You've been listening to The Future Of, a podcast powered by Curtin University. If you've enjoyed this episode, please share it. And if you want to hear more from experts, stay up to date by subscribing to us on your favourite podcast app. Bye for now.